Welcome back. We are now going to talk about quadratics in the intercept form. Again, you need to memorize intercept form. It's y equals a times x minus p times x minus q, where p and q are x-intercepts of the quadratic. So here's a picture of it. You can see p's an x-intercept, q's an x-intercept, so y has to equal some value a times x minus p times x minus q. Okay, characteristics of the graph y equals a times x minus p times x minus q. Well, the x-intercepts are p0, q0. The axis of symmetry is halfway between p0 and q0, so it has the equation x equals p plus q over 2. You take the average of p and q. Now, remember, this is also going to be the x-coordinate of your vertex. Okay, so you can find the x-coordinate of your vertex. Do you remember from standard form how you can find the y-coordinates of a vertex if you know the x-coordinate? Right, you take the x-coordinate and you plug it into the function and you'll generate the y-coordinate. Again, the graph opens up if a is positive and opens down if a is negative. All right, so let's graph a function, a quadratic function in intercept form. We've got y equals 2 times x plus 3 times x minus 1. Now remember, it's x minus p and x minus q. So that x plus 3 we're going to have to think of as minus negative 3. All right, so we want to identify the x-intercepts in step 1. Okay, p is negative 3 and q is 1, because remember it's x minus negative 3, so p is negative 3. The x-intercepts occur at the points negative 3, 0, and 1, 0. Step 2, you're going to find the coordinates of the vertex. So for the x coordinate, you take the average of p and q, so it's p plus q over 2. So negative 3 plus 1 over 2 gives us negative 2 over 2, which is negative 1. Okay, again, remember, anytime you know an x value and you want to find the corresponding y value, you just plug in the x value. So we have 2 times negative 1, our x value, plus 3 times negative 1 minus 1. And so that gives us 2 times negative 2, which is negative 8. So we're going to draw the parabola through the vertex, negative 1, negative 8, and where the x-intercepts occur. So negative 3, 0, and 1, 0. And you just draw that in. Okay, let's look at an example of football. The path of a place-kicked football can be modeled by the function y equals negative 0.02x times x minus 46, where x is the horizontal distance in yards and y is the corresponding height in yards. So x is horizontal distance, so that's the how far, and y is the corresponding height, so that's the how high. A, how far is the football kicked, so that's going to be something with x. And what is the football's maximum height? That's going to have something to do with y. All right, so we want to rewrite the function as y equals negative 0.026, and instead of just times x, we're going to write times x minus 0, because they are equivalent, but this puts it in intercept form, times x minus 46. All right, so that means p is 0 and q is 46. Since we know the x-intercepts are 0 and 46, you can do 46 minus 0 is 46, and you can conclude that the football's kicked a distance of 46 yards. Okay, to find the football's maximum height, calculate the coordinates of the vertex, because the maximum value is going to be the y value of the vertex. But to find the y value, you have to have the x value. So you take the average of your p's and q's, so p plus q over 2 gives us 46 over 2, which is 23. And now you take the 23 and plug it in, and you get y equals negative 0.026 times 23 minus 46, which is negative 23. And you multiply those together, and you get approximately 13.8. So the maximum height is the y-coordinate of the vertex, or about 13.8 yards. Okay, so we've been introduced to intercept form and to vertex form. But last class period we talked about standard form, and sometimes that's how we want our equations written as a final answer. And so we're going to practice moving from intercept form to standard form, and then we're going to go back and look at vertex form again, which makes a nice little review here at the end of this video, and we'll convert it to standard form. Okay, so we have y equals -2 times x plus 5 times x minus 8, and we want to write it in standard form. So you have to think to yourself, well, what is standard form? Well, that's y equals ax squared plus bx plus c. So that means we want to simplify what we have. All right, so we can do that. So write down the original function, y equals -2 times x plus 5 times x minus 8, and then you want to FOIL the x plus 5 times the x minus 8, and so that gives you x squared minus 8x plus 5x minus 40 in your parentheses there with the -2 out front. Remember, you need to be simplified inside these parentheses at this point before you multiply, so we want to combine like terms. So -8x plus 5x is -3x. So we have -2 times x squared times -3x minus 40. What do we do next? Well, we distribute the -2. So we get -2x squared plus 6x plus 80. And that gives us our final answer in standard form, y equals -2x squared plus 6x plus 80. Now, you do need the y equals part. Okay, it either needs to be in y equals ax squared plus bx plus c form, or you can have function notation and have f of x equals ax squared plus bx plus c. Okay, so for our last example, we're going to write f of x equals 4 times x minus 1 squared plus 9 in standard form. So we need to simplify all that's written on the right-hand side. So we write the original function, f of x equals 4 times x minus 1 squared plus 9. And then we're going to rewrite x minus 1 squared as x minus 1 times x minus 1. That's what it means. And that makes it a little clearer. We're looking at this, we've got 4 times x minus 1 times x minus 1, and then plus 9. We need to simplify that 4 times x minus 1 times x minus 1, and then worry about adding 9 at the very end. Well, let's go ahead and multiply the x minus 1 times x minus 1 using FOIL. So that gives us our 4 that we just bring down, and then from our FOILing we get x squared minus x minus another x plus 1, and then we've got our plus 9 tacked on at the end, which is going to be our last thing to do. All right, again, you want to combine like terms. -x minus x is -2x. So we have 4 times x squared minus 2x plus 1, and then a plus 9 at the very end. We'll use our distributive property to get 4x squared minus 8x plus 4, and then we've got our plus 9 at the end, and we combine like terms. And we get 4x squared minus 8x plus 13. So that's ax squared plus bx plus c form. We just need to write it as y equals. So y equals 4x squared minus 8x plus 13. And that is our final answer because that's y equals ax squared plus bx plus c. Okay, guys, so today we've learned two forms. We've learned the vertex form, which is great because it tells us what the vertex is. It makes it real easy. Then we find 2 points, reflect across the axis of symmetry to get 2 more, and draw in our parabola. Really nice form to have. We found intercept form, and so for intercept form you plot the two x-intercepts, and then you calculate the x value of the vertex by taking the average of the p plus q, so it's p plus q over 2. And then you plug in that value to get the y value of the vertex. We looked at moving from both those forms to standard form. So what I need you to do is go through and do the 2 problems to try on your own. Notice that there's some things that you need to label on the graph. For instance, for the first one, you're to graph the function and then label the vertex and the axis of symmetry, and then write the equation in standard form. Make sure you do all those things. Okay, well that's it. Y'all have a good afternoon or evening or morning whenever you're watching this, and I will see you in class next time. Bye.